everyone. Welcome to the video tutorial series of the wireless communication. I am an instructor Varshata. Let's start our today's lecture series. So at the end of this video, you will be able to learn about the SDR, that is software defined radio, and we will learn about the UWB, that is ultra wideband radio. So now let's start with our first topic, that is SDR. SDR is based on, that is a software defined radio. The basic concept of the SDR, that software radio, is that the radio can be totally configured or defined by the software. Okay, how we can define the software defined? Because the radio that is totally dependent on the software. So we can say that is the software defined radio is that. So it is configured or defined by the software so that a common platform can be used across the numbers of the area. So you can use this radio across the numbers of the area because it is a software defined. So how we can define this? Radio in which some or all the physical layer functions are the software defined. So it is known as the software defined radio. Radios that provide the software control for the variety of the modulation techniques. So different modulation techniques can be available when the software defined radio is there. So as the name suggests, software defined radio is the radio system where the majority of the baseband processing that is done at the physical layer functions. So that is done in the software, which includes, what it includes? It includes the modulation, forward error correction is there, spreading is there, filtering is there, frequency time synchronization is there. So and many more functionalities are there. You can use the different modulation technique. You can use the forward correction, error correction methods to correct the error in the signals if there is any. Spreading, okay? Spreading of the signal. For the spreading of the signals, we have learned so many things, that is FHSS and DSSS is there. Filtering, you can use the different types of filter, for example, band pass filter. Frequency timing synchronization, and these are the many more functionality that is available when you are using the software defined radio. Now, let's see the concept of the software defined radio. You know what is the software is? Okay. So software is that part of the computer system that consists of the encoded information or the computer instruction in contrast to the physical hardware from which the system is built. Now all of you are about the software. Okay, software that is based on the computer system, that is based on the hardware that is installed in the computer system. On that hardware you are able to execute this software. Okay, now what is radio? Okay, so radio and software both are the totally different things. So radio is the technology using the radio waves to carry the information such as the sound by systematically modulating some property of the electronic energy waves transmitted through the space, such as their amplitude, frequency, phase or pulse width. Okay, so radio that is used to carrying the information. Okay, that it is, for example, in terms of the sound. Okay, so what is radio? Radio is for the carrying the information. For example, you are listening the radio channels in your radio stations. So that is what? They are carrying the informations to you and you are listening that radio signals. Okay, when software meets the radio, that will become a software defined radio. So why the software meets radio? Why it is necessary? Why we have to use? Why we have to combine the software and the radio? What is the need of it? So there are the certain crucial drawback of the pure radio system, that is least flexibility is that. Then design cost is very high in the simple radio. Then the possibility of the updating to new technology, that is very difficult in the simple radio. But if it is a software defined, then it will become easy. Why easy? Because all you know, if new software update will come, you can update your mobile system if new update will come. So same way, if the radio is combined with the software, it is very easy to update that system. So because of this drawback, they are addressed by incorporating the software along with the hardware radios. So which are the hardware platform includes? So that field programmable gate arrays, that is FPGA, then digital signal processor, that is DSP, then the general purpose processor, that is GPP, and the programmable system on the chip, that is SoC, or the other application specific programmable processors are there. Then operating environment like hardware resources and management you will require in the STR, and the software module like the link layer protocol, in which you will use the wireless application protocol or the web protocol, because we are using the software defined radio, that's why. Now this is a figure for the software defined radio. Here different blocks are connected with the IO devices, and here this will monitor its entire status of this blocks. Okay, I is for the information, C is for the control status, IF for the intermediate flex, etc. So this figure this define the software defined radio. Now which are the different STR technologies are there? Okay, so three different technologies are there: intelligent radio, cognitive radio, and adaptive radio. This figure we can consider as a Venn diagram. Why? Because intelligent radio, that it is the inner part. Adaptive radio, that is the combination of the cognitive radio and the intelligent radio. In cognitive radio, intelligent radio is there. So like this, we can consider this figure as a Venn diagram. Now what is the adaptive radio? The communication parameters can modify the parameters. Then the greater degree of the freedom in the adoption. So this is known as the adaptive radio. As the name suggests, the adaptive radio, that means you are editing the different technology as it will come. Then next one is the cognitive radio. So system is aware of the internal state of the state and the environment. So utilizations of the critical end users are there in the cognitive radio. It reduces cost to the end user. Then last one is the intelligent radio. So it is capable of the machine learning. Okay, intelligent radio, as the name suggests, it can do anything. It can do all the tasks. It allows the radio to improve ways to adopt the changes in the performance. It allows to radio to improve the ways. It allows the radio to change in the technology also. Okay, so that's why it is known as the intelligent radio. Now, what are the advantages of the STR? What are the advantages of the software defined radio? Okay, so software to be reused across the radio products. You can use the same software through the different radio products, over the air or the other remote programming. Okay, you can use it over the air or for the other remote programming also. It allows the bug fixes because we are using the software, that's why. It reduces the cost in the providing end user with the best connectivity. Okay, so cost for the end user will be reduced in the STR. So these are the advantages of the STR. Then let's see the next radio, that is UWB. Now UWB stands for the ultra wideband. Okay, ultra wideband provides the wireless broadband system. It supports the high transfer rates and digital video. As its name suggests, ultra wideband. Ultra wideband, that means it has the much more capability. Okay, 1 Mbps and low data consumptions are there in the UWB. Short range operations up to 10 meters can be performed. It is used to transmit the binary information in the binary information requiring. Now UWB technology stands the small digital impulses that spaced by the very precisely in time. In time, that means intervals in the order of the 10 picoseconds. So across a wide number of the frequency channel at the same time. The duration of the short pulse is typically less than the nanoseconds. Okay, so that is in the terms of the nanoseconds. The signals used in the UWB, that is signals used in the ultra wideband technology, can be generated through the variety of the methods. Which methods? One can be through the use of the source of the narrowband pulses and make them go through the band pass filters. Okay, so band pass filter, that means the noise will be removed, etc. Now here you can see this figure shows the ultra wideband. Here this is the frequency domain behavior is there, and here this is the time domain behavior is there. So how in the time domain and how the signal will be walk in the frequency domain. Okay, so this is defined in this figure. Now what are the features of the UWB? So features, that is or we can say the advantages of the UWB, that is the high transfer rate is that. Why high transfer rate? Because we are using the ultra wideband. If ultra wideband is that, then the capacity is much more than the other radio. Low power consumption is that, and immunity to the external interference is that. Now let's see the advantage. Large channel capacity. Okay, ability to share the spectrum, that ability to work with the low SNR, that is SNR, that means signal to noise ratio. Okay, so signal to noise ratio will be there, less will be there, low probability of the detection is there, resistance to jamming. Okay, jamming of the signals will not happen in this. High performance in the multipath channel is there. So these are the advantage of the ultra wideband. Now what is the disadvantage of it? It operates at the higher frequency gain and cannot be increased. So this is the disadvantage of the ultra wideband technology. So in this video we have learned about the SDR, that is the software defined radio. Okay, how it is works. There are different ranges there, like a cognitive radio, adaptive radio, and intelligent radio is there. Okay, and then we have learned about the UWB, that is ultra wideband radio. Ultra wideband, that means it has the more capability. Okay, that we have learned in this lecture. So thank you for watching. We will meet in the next lecture. Thank you.